during a tornado. You might hear a storm chaser yell, "Satellite." Or perhaps, "Landspout." Or even, "Wedge." But it's very unlikely you'll hear someone yell, "Non-mesocyclonic tornado," or "quasi-linear convective system tornado."
Oh my god.
Over the years, I've managed to document every type of tornado, except one. So here are my captures of every type of tornado. So cool. And the one I had the license from Daniel. All the different types of tornadoes can be divided into two broad categories, mesocyclonic and non-mesocyclonic. Some can then be further classified by behavior, formation mechanism, and relative locations within the thunderstorm. Many of you already know the biggest, baddest tornadoes develop from a powerful breed of thunderstorms called supercells. Supercells are thunderstorms that have an organized and persistent rotating updraft called a mesocyclone. These mesocyclones are powerful forces of nature, and tornadoes born from them have the largest impact on lives and property. And so, mesocyclonic tornadoes are the type we are most familiar with. But some tornadoes spin up from ordinary thunderstorms that don't have mesocyclones.
All right, we got a weak hook echo tornado thingy here.
This variety is classified as non-mesocyclonic and is commonly known as landspouts. Landspouts generally fall on the weaker side of the tornado intensity spectrum, but strong ones have been reported. A fascinating thing about landspouts is they can sometimes develop from just a rapidly growing cumulus cloud before it even becomes a thunderstorm. On several occasions, I've seen a newly developing thunderstorm initially produce a landspout, and then the storm organized into a supercell, producing a mesocyclonic tornado. When a tornado forms or moves over a body of water, we call it a waterspout. Like landspouts, most waterspouts are non-mesocyclonic and typically dissipate shortly after moving ashore. But here's the part that doesn't seem well thought out. Any tornado over water is called a waterspout, even a mesocyclonic tornado. Despite flopping around in the Gulf of Mexico my whole life and targeting waterspouts around the world whenever I can, I still have never seen one. Sooner or later, my waterspout repellent has got to wear off somewhere. Thanks for letting me vent. Moving on. The next type of tornado we're going to visit is the multiple-vortex tornado. A multiple-vortex tornado contains evil, smaller vortices called suction vortices revolving inside the main vortex near the ground. Both mesocyclonic and non-mesocyclonic tornadoes can become multiple vortex tornadoes, as can other types of non-tornadic vortices that interact with the ground, such as dust devils and gustnados, which we'll get into in a bit. A tornado's destructive power can dramatically increase within suction vortices. This helps explain why intense destruction can occur bewilderingly close to objects experiencing minimal damage. What might seem like the chosen and the spared is simply the random nature of vortex physics.
Might need to back up.
Suction vortices can suddenly appear and disappear, taking turns existing as they grind around inside the parent vortex.
Yep, time to back up.
Most exist for only a few seconds, but in larger tornadoes, they can persist for a minute, traveling more than halfway around the tornado.
Come on, car, go.
With a large funnel cloud churning overhead, I've watched tiny suction vortices only a meter or two tall buzzing through a field, likely terrifying lizards and grasshoppers. When suction vortices travel over soil or farmland, or solar farms, they can carve looping or arcing scars into the ground known as cycloidal marks. Back in 2016, I recall one particularly strange multiple-vortex tornado in Oklahoma. What I thought were separate tornadoes developing was actually a carousel of giant suction vortices. What's weirder is some of those giant suction vortices had suction vortices of their own.
It's 2 of them!
Much like a moon orbiting a planet, a satellite tornado revolves around a parent tornado or parent circulation.
It's a big one.
Unlike a multiple vortex tornado where the suction vortices are components of the same tornado, the satellite and the parent are considered 2 separate tornadoes. Back in 2004, before chasers knew how to hold a camera steady,
About to happen.
I witnessed my first satellite.
Oh, here goes, man.
Got it all.
Hold on, we're sliding all over the place.
The thing I want to point out here is that the parent circulation doesn't have to be a tornado for a satellite to occur.
Videotaping?
Hell yeah.
Most tornadoes are cyclonic, meaning they spin the same direction as the Earth. That's counterclockwise in the northern hemisphere and clockwise in the southern. So if you're watching a tornado in the northern hemisphere, it'll most likely be spinning from left to right. But every now and then, a tornado spins the other way.
Oh my god, that thing is a walkabout. And it's anticyclonic.
We refer to these deviants as anticyclonic tornadoes.
It's a long-lived anticyclonic too.
Wow, that's pretty. Satellite tornadoes can be anticyclonic, and landspouts are sometimes anticyclonic. But most of the anticyclonic tornadoes I've observed developed in a visually recognizable region sometimes present in supercells, known as the meso-anticyclone. In this high-resolution radar simulation of a supercell, you can see the regions where a mesocyclone and companion counter-rotating meso-anticyclone develop. Watch how closely this pattern resembles our dry ice experiments.
That's what we're after. All right. Bam!
The next type of tornado we'll explore develops along squall lines and is categorized as mesocyclonic. Sort of. A squall line, technically called a quasi-linear convective system, or QLCS, is a long, organized line of thunderstorms that commonly stretch for several hundred kilometers. Embedded within some squall lines are rotating circulations called mesovortices. While usually smaller and shorter-lived than the mesocyclones found in supercells, these hybrid circulations can sometimes produce tornadoes near the leading edge of the squall line. QLCS tornadoes tend to lean toward the weaker side of the tornado intensity spectrum and are believed to account for roughly 20% of reported tornadoes in the United States. For storm chasers, they're among the most difficult tornadoes to capture, and many of us don't even bother.
Oh, there's the tornado crossing the road right in front of us.
Babe,
Guy's about to get hit.
hang.
I know, we're here. I got this. This is what we came for.
Oh my god. It's too close.
I know. It's hard to predict if or where a mesovortex will develop, and when a tornado does form, it's often brief and hidden by rain within the endless line of storms.
All right, babe, what'd you think? Can you even see us with this big old thing in the way? Look, you can't even see. I need to move that camera.
I got super freaked out.
Yeah, it's pretty scary.
It's just too close.
And the clouds above you, what were the clouds doing straight up above you? You did great. You did great. That was close, and There was only one road. The QLCS was blowing over us. All the clouds were contorting. That would have been terrifying for anybody. You did great.
Well, thank you.
Okay, we have a nice funnel cloud building down towards the ground.
We're on formation.
We should probably mention funnel clouds, which are just that. They rotate and dangle below the cloud base, but the circulation may or may not be in contact with the ground. Once strong rotation is in contact with the surface, the vortex is officially a tornado.
So cool.
Occasionally, funnel clouds form horizontally, and sometimes horizontal vortices can be seen twisting and writhing around powerful tornadoes. You might even hear some chasers refer to these as noodles. All of the tornadoes described so far can be further informally described by their shape. The most common one you'll hear a chaser scream is probably wedge. A wedge is a tornado that appears wider than it is tall. These massive, deeply unsettling tornadoes often exceed a mile in width.
Alright, this is dangerous. Holy cow.
A drill bit is a powerful thin tornado spewing debris.
Unbelievable.
Another common shape is the stovepipe because it resembles a stovepipe. And then there's the cone because it resembles an apple, and the rope because it resembles grapes, and the elephant trunk because it resembles a library. And we absolutely must not leave out the bird fart. Yeah, it's a thing. Bird fart not only describes tiny short-lived spin-ups beneath storms, but the term can also be used to belittle an overzealous chaser. If a weak spin-up occurs and your buddy screams, "Tornado!" it's your civic duty to respond, "Bird fart." A gustnado is a short-lived, generally weak vortex that spins up along a thunderstorm's gust front and other currents. Unlike a tornado, it is not connected to the storm's updraft. They can be dead ringers for weak tornadoes and are often mistaken as them. The best way to protect yourself from a gustnado is to roll the window up.
Yay, I'm inside a gustnado.
A dust devil is a small but vigorous rotating column of air not associated with thunderstorms, rendered visible by dust or sand or whatever happens to be lying around.
There's little llama turds going in circles.
Run into it!
They best develop on hot, calm, sunny afternoons when dry ground becomes intensely heated, causing the air near the surface to rise rapidly.
Debris!
Check out this multiple-vortex dust devil.
Yeah, go run it. There's like 4 vortices rotating around. No, you're definitely getting covered in llama when you're out there.
A vortex can be named by whatever it happens to be carrying, from a dust devils to steam devils, fire whirls to snow whirls. A firenado, or fire whirl, is not a true meteorological tornado. It is simply a fire-enhanced vortex created by the extreme heat and rising air. Though I haven't been able to capture a good example of a fire whirl yet, one magical day back in 2014, the team I was collaborating with was able to document the world's first glitter tornado, or sparkle-nado. Man, what a day.